Hi everyone, welcome to PharmaExplora. Today we are going to discuss another interesting topic. I hope you remember in our previous sessions we have discussed what is pharmacology. So we define the pharmacology as science of medicine which explain the entire biography of a medicine. So this pharmacology explains the origin of the medicine, physical and chemical properties of the medicine, and also, most importantly, the biochemical effects and the physiological mechanisms that particular medicine is going to generate. And we further discussed this pharmacology is divided into two main categories, the pharmacokinetics and the pharmacodynamics. So these two disciplines are like the two sides of the same coin. So in our previous sessions, we have discussed one side of this coin, that is pharmacokinetics. So we define the pharmacokinetics as what our body does to the drug, or in more formal way, what the effect of biological systems on medicines. Today we are going to discuss about the other side of the coin, that is pharmacodynamics. In simple terms, what drug does to our body. So today we are planning to discuss what is pharmacodynamics, then what are drug receptors, what we call by the drug receptor complex, and what is the signal transduction process, and as well as, most interestingly, the scientist who significantly contributed to develop this discipline. So today we will be discussing this overview of pharmacodynamics. Let's get started. Okay, have you ever think how does a particular drug molecule, once it reaches its target or the destination or maybe the site of action, how does that particular drug molecule actually work? Or in other words, we can say, have you ever think how does a particular drug molecule changes the way of your heart beats, or reduce your stomachache, or stop your headache? That particular discipline is called pharmacodynamics. So pharmacodynamics we simply define as what drug does to our body. So more formal way we can define the pharmacodynamics as the study of biochemical effects and physiological effects that particular medicine is going to generate on our body. And also, this pharmacodynamic discipline explains the concentration of a drug molecule at the site of action, how influence the strength or the magnitude of the biological response that particular medicine is going to generate. So let me explain again. So I hope you can remember our main theme, pharmacology. We divided into two main disciplines. Pharmacology, we divided into two main disciplines. So first one, pharmacokinetics. First one, pharmacokinetics. We define pharmacokinetics as what our body does to the drug, and we explain that pharmacokinetics will determine the movement and the fate of a drug molecule from the moment it enters to our body until it leaves from our body. So to elaborate this complex journey, we discussed about ADME framework under pharmacodynamics. So ADME stands for absorption, distribution, metabolism and elimination of particular drug molecule. So today we are moving to the other side of the coin, that is pharmacodynamics. Pharmacodynamics. So we, in simple terms, we define pharmacodynamics as what? Pharmacodynamics as what the drug does to the body. So we define as what drug does to the body. So, in more formal way, we define this pharmacodynamics as the study of the effect of biochemical effects and physiological effects of a drug molecule on human body. So, and also we stated that the pharmacodynamics explained the how the concentration of a particular drug molecule at its site of action is going to influence the magnitude or the strength of the biological response that particular medicine is going to generate. So this is basically what pharmacodynamic is. Okay, now we are going to discuss what is a receptor is. So most of the drug molecules just don't float aimlessly. They have a specific target or specific receptor to go and interact with. So, most of the drug molecules produce their effect by interacting with these receptors. So, they exert their effect by interacting with these receptors. This effect can be sometimes beneficial and sometimes harmful. So, the beneficial effects are the effects that we want, and the harmful effects are the effects that we don't want. So, this receptor can be defined as the specialized target macromolecule. Specialized, highly specialized target macromolecule. So, in biology, we define macromolecule as the large complex molecule that may be made up of protein, the polysaccharide, or sometimes nucleic acid. So, these receptors or the highly specialized macromolecules are sometimes sitting on the surface of the cell, or sometimes they are tucked away inside it. So, we can explain or we can say these receptors are highly specific signal detectors or the molecular locks waiting for the right key to open them. So the right key is the correct drug molecule. So the receptor is we can define as the highly specialized signal detector waiting for the right key to open it. Okay, now we are going to discuss the most important drug receptor complex. We are going to discuss about the drug receptor complex, very, very important. So in our previous parts, we have discussed that the drug molecules just doesn't float aimlessly. They have specific receptor to go and bind with. So once this drug molecule goes and finds its specific receptor and binds to it, they form, we call the drug receptor complex. So once the drug molecule, or we oftenly say ligand goes and finds its receptor, they form what we call drug receptor complex. They form drug receptor complex. So the drug molecule or the ligand find its specific receptor, it forms its specific receptor and form its drug receptor complex. So let me explain the ligand also here. In pharmacology, we commonly use this term ligand. So ligand is the any substance that can cause, ligand is the any substance. So it can be either drug molecule, hormone, neurotransmitter, which can bind to its specific receptor and generate biological response. So we in pharmacology we often very commonly use this term ligand. Ligand is the any substance. It can be either drug molecule, hormone or the neurotransmitter which can bind to its specific receptor and generate a biological response. Now what we were discussing is about the drug receptor complex. So once the drug molecule finds its specific receptor, we discussed that they form this drug receptor complex. This is not merely a physical attachment. Why? This drug receptor complex is the initiation of the entire biochemical and the molecular level activity or the alterations within the cell that particular drug molecule is going to generate. So, the drug receptor complex is not merely a physical attachment, it is the initiation of the entire the biochemical and molecular level alterations caused within the cell due to this drug molecule. So, we can also say it's like molecular level handshake. The, the formation of the drug receptor complex is like molecular level handshake. Why? In handshake, what will happen? When we once we identify a person, so the first step recognition. Then we go to the attraction and the interaction or the communication happens. So in a good handshake, the recognition, the attraction, and the communication or the interaction happen. So same like the formation of the drug receptor complex. So we also define this as the molecular level handshake. Molecular handshake. Why? Because this drug receptor complex is not only a physical attachment. So this drug receptor complex initiates an entire series of effects which will ultimately lead to the final effect or the final response that this drug molecule is going to create. Now you can see this drug molecule doesn't itself do its job. This drug molecule doesn't itself do its job. What this drug molecule do? It binds to its specific receptor and form the drug receptor complex, and this drug receptor complex is the one who initiate the entire process. So this drug molecule doesn't do the job itself, but it sends the message to do the entire process. So that is what the drug receptor complex is. Okay, now we are coming to an interesting part of our topic. We are going to discuss what is signal transduction. What is signal transduction? So in our previous part, we discussed that the drug molecules, they don't float aimlessly. They have specific receptor to go and bind with. So once the drug molecule goes and finds its specific receptor, they form a drug receptor complex. Form a drug receptor complex. This drug receptor complex is not merely a physical attachment. That is not merely a physical attachment. It is the initiation of the entire biochemical and the physiological effects that particular drug molecule is going to generate. So we introduce this drug receptor complex as the formation of drug receptor complex as the molecular level handshake. So how does this molecular level handshake or the molecular activities going to turn into a real world effect that we can see? So the question is, how does the molecular level activity is going to cause a real world effect that we can see, like lowering blood pressure, lowering blood sugar, or sometimes reducing pain, etc. So that process is called signal transduction. signal transduction. So signal transduction acts as the bridge between the drug receptor complex activation and the final effect. So this signal transduction acts as the bridge between the drug receptor complex activation, drug receptor complex activation and the final effect. So this final effect can be what we can see: lowering blood pressure, lowering blood sugar, or reducing pain, etc. So this is act as the bridge. So let me explain it again. Now these drug molecules, they just don't float aimlessly. These drug molecules, they just don't float aimlessly. So these drug molecules float and find its specific receptor. They goes and find its specific receptor. So drug molecules goes and find its specific receptor, and they form a what we call drug receptor complex. So drug molecule goes and finds its specific receptor and form the drug receptor complex. So this drug receptor complex then gets activated and they initiate alterations of biochemical activities and molecular activities of a cell. This drug receptor complex gets activated and they initiate alterations in the biochemical activities and molecular level activities of a cell. That process is called signal transduction. So that process is called signal transduction. So the drug molecules goes and find its specific receptor and form a drug receptor complex, and they get activated, and then they initiate a series of biochemical effects and the molecular level effects. So which within the cell, that process is called signal transduction process. So we can also define this. We can take an example and explain it like this is like a relay race which consists of 3 steps. Like a relay race which consists of 3 steps. First one, reception. The second one, transduction. And the third one, response. This is like a response. This is we can also explain as an example. So as a relay race which consists of 3 steps: reception, transduction and response. So the reception is the drug molecule goes and finds its specific receptor and binds to it and form the drug receptor complex. That is the reception, the first one. So the drug molecule is the one who takes the baton, the first runner. So drug molecule is the first runner taking the baton, and goes and find its specific receptor and passes over the baton. So this receptor forms the drug receptor complex and get activated. Then the transduction, the second step. During the transduction, what will happen? The drug receptor complex get activated and it initiates a series of the series of reactions, the molecular reactions as well as the biochemical reactions, which is caused within the cell, and it will cause the final effect. the response. The response is caused by, response is like final runner finishing the race. So once through the transduction, once the series of biochemical and molecular level activities happen, the response occurs. So the response can be like opening an ion channel or activating hormone. That is the response to this activation of the drug receptor complex. So this is what we call the signal transduction process. Okay, now we are going to discuss a key principle in pharmacodynamics, which is very helpful clinicians in practical settings. So, pharmacodynamics we define as what drug does to the body. Under that, now we are going to discuss the relationship between the drug concentration versus the response that particular drug molecule going to generate. The relationship between the drug concentration versus the response that particular drug molecule is going to generate. So this is very important statement. So we state that the amount of drug molecule present at the site of action is determined the strength of the response of the particular drug molecule is going to generate. So the amount of the drug molecule present at its site of action will determine the strength of the response. So the amount of the drug molecule present at its site of action is going to determine the strength of the response. Is going to determine the strength of the response. This is very important concept for clinicians in practical setting. So the amount of the drug molecules present at its site of action is going to determine the strength of the response. So let me explain it again. Now it's like this. You imagine only a very few drug molecules present in a site of action. So very few drug molecules are present at its site of action. Only a few. So what will happen if only few drug molecules present at its site of action? Only few receptors will occupy. Only very few receptors will occupy. Few receptors will occupy. So ultimately what will happen? The response is weak. That will generate a weaker response. If only few drug molecules present, few receptors will occupy and the response will be weak. Then as we are increasing the dose, if we increase the dose of if we increase the concentration of the drug molecule, what will happen? More drug molecules, so more receptors will get activated and response will gradually increase. Response will gradually increase. Response will gradually increase. And when we are increasing the drug concentration, there will be a certain point that all the drug receptors present in its site of action will be fully occupied with drug molecules. So there will be a certain point all drug receptors will be occupied with the drug molecule. So that is the point where you can get the maximum response. So that is the point where you can get the maximum response. So this is very important for clinicians to understand, to give the right dose for a patient to treat disease, avoiding the toxicity. So this concept is very important for clinicians to decide the right dose of a particular medicine to treat a disease for a patient, avoiding toxicity. So let me explain it again. At the site of action, only few drug molecules are present, the few receptors will occupy and the response will be weak. If we increase the dose of the drug molecule or increase the concentration of the drug molecule, the more receptors will bind to the drug molecules will go and find more receptors and the response will be gradually increased. And there will be a point where all the receptors will be occupied with these drug molecules. So that is the point where you can get the maximum effect. So this is very important for clinicians to determine the right dose for a particular medicine to treat a disease, avoiding the toxicity. So pharmacodynamics perfectly find to balance this using this concept. So this is the relationship between the amount of the drug molecules present at its site of action versus the strength of the response. Okay, now we are coming to a fascinating part of our discussion. Now we are going to discuss the greater contributions done by scientists to develop this pharmacodynamic discipline. Same as the pharmacokinetic discipline, pharmacodynamic field is not a single scientist discovery. This field also gradually evolved from the contributions made by scientists. So now we are going to discuss three main scientists who contributed significantly to develop this discipline. Our first scientist is Paul Ehrlich. So Paul Ehrlich, over 100 years ago, he stated that the drugs cannot act unless they are bound to something. So this German scientist stated over 100 years ago that drugs cannot act unless they are bound to something. So he stated that substances do not act unless they are bound to something, and he stated that bounding factor is receptor. So this is his discovery led pharmacodynamics into a next step. So then the second scientist, John Newport Langley. So this is a British physiologist. So he observed that certain chemicals like nicotine, curare competed for the same spot on the muscle. Competed for the same spot on the muscle. That is how it led to the discovery of specific binding sites of drug molecules. So this discovery of John Newport Langley led to finally identify the specific binding sites of the drug molecules. Then comes the third one, Professor Alfred Joseph Clark. Professor Alfred Joseph Clark, in 1920s, he developed this occupation theory. He developed the theory called occupation theory. So in this occupation theory, he stated that the magnitude of the drug's response directly proportional to the number of receptors it occupies. So in 1920s, he came up with the proposed or theory, the occupation theory, which explained that the magnitude of drug's effect is directly proportional to the number of receptors it occupies. So you can see how this discovery has helped to evolve this pharmacodynamic discipline. So the Paul Ulrich, John Newport Langley, and the Professor Alfred Joseph Clark are significant the scientists, great scientists who have significantly contributed to evolve this pharmacodynamic discipline. Okay, to wrap up, today we discussed about overview of pharmacodynamics. So our main theme was pharmacology, and we discussed that pharmacology has two main categories, pharmacokinetics and pharmacodynamics. So those two categories we explained as the two sides of the coin. So today we discuss the other side of the coin, that is pharmacodynamics. In simple terms, what the drug does to our body. We can say the effect of the drugs we are taking on biological systems. So under pharmacodynamics, we learned how drug molecules goes and binds to its specific receptors and triggers the signal transduction process and ultimately or eventually leads to its biological response. So that is basically the mechanism of action of a drug molecule. So this pharmacodynamic discipline, we can say it explains the how and why behind every drug that we are taking. So I hope you learned something from this video. If you enjoyed from this video, just hit the subscribe button and stay tuned for our next session. Thank you for joining with PharmaExplora today and see you soon.